welcome everyone to Madison-AI, or MadAI, co-sponsored by IEEE Madison and the Madison IEEE Computer Society. The pizza is sponsored by IEEE, so thank you, IEEE. We are here to talk about vibe coding in general, but really focused in on Claude Code and understanding how development within the tool sets is progressing, and understand them and really talk about them. But first, before I do, I have an amazing, esteemed professor from the university here to give a brief introduction about what the UW is doing, the University of Wisconsin, in computers. So please.
Thanks. Okay, so I should stand here. So I'm at, oh yeah, I can see. That's horrifying. So hello, everybody. My name is Remzi Arpachi-Dussault. I've been a professor in the computer sciences department since Jim Gass was a student. So since January 2000. And lately, I've been in a new role on campus. Actually, two new roles. One is an advisor to the provost on computing, but secondly, as the director of what's called the School of Computer Data and Information Sciences. That's a school still within the College of Letters and Science that brings together the CS department and the statistics department and the information school. And there's just an increasing intellectual overlap between the computer sciences, call them, and statistics and data sciences and information sciences is why we brought those units together. And for the last 6 years, we've been operating as a quasi-unit. We've done things like introduce the new data science major. It went from having exactly 0 students because it didn't exist to being the second biggest major on campus. We house also the computer science major, which has gone from being a small major for people who are only really into computing to being the biggest major on campus. Of course, most of those students double, triple major with all sorts of other things. A really interesting time on campus, I think, to be a student. And we are just moving into a new building. You may have, if you drive down University, you may see Morgridge Hall, which has been under construction for the past couple of years. It's now open, so feel free to just come walk around during office hours, which is normal business hours. And I do hope that we can host some future event or events in the new space. It's just a fantastic space, state-of-the-art building, all privately fundraised, which means it can be nicer than most buildings on campus. I probably shouldn't say that in some sort of recorded way. But yeah, it feels like not quite like a public school. But it's a super nice space, and I hope that we can figure out how to utilize it to help build further this kind of community that you've already built and connect with you all. I think students would be, I mean, maybe some here, but like so many opportunities, I think, to interact. And you know, I don't have like a big spiel to say, but I'll just talk about a couple of directions that we're headed in. One thing that we're actually considering right now is the word I'm supposed to use about this, which is CDIS has existed as this kind of quasi-college, right? So there's an engineering college with a dean and, you know, business and law and all those things. And our construct has been still within the College of Letters and Science, which is huge. You know, College of Letters and Science, which is a great home, is about as big as Northwestern, right? It's a huge college within a much bigger university. But there's some serious discussion about the 3 departments pulling out and being an independent unit. Not to be separate, really, but to have a dean and to be able to actually do more things with the whole campus around computing, around AI. And certainly this AI moment that we're all living through, that you're going to be talking about today in a very real way, it's certainly affecting everybody. And having a unit that maybe can be the center point of that, not the only place where that stuff happens, but a center point is why I think we're in the discussions and trying to figure out what that would look like. So pretty exciting that way. We're also just trying to do more programmatic things. We were really fortunate to have Chris this summer serve as a mentor for students in a program that we did jointly with OpenAI. We called it SAIL, Summer AI Laboratory, where students just did open-ended projects mentored by people in the local community. We certainly want to help build that mentor network so students can connect to the folks that live around here and are professionals. And we, I think, saw a great example of how fun it was to kind of hang out together and do cool projects.
And the students did amazing work. Just looking at some of the cool projects, some of them may even be on a YouTube channel here shortly. But like, just amazing work by undergraduate students And like the UW is doing some really cool stuff, and that's part of the reason why we're talking about the UW. So thank you.
Yeah. So thanks, and looking forward to further interactions. Unfortunately, I can't stay today. I would love to actually see what you're talking about, but I'm sure we'll connect again at whatever the next thing is.
Wonderful.
All right.
All right.
Very much.
Give it up.
Oh yeah. Thanks. I'm gonna force this on here. Oh, there we go. Here you go. Thanks so much.
Thank you.
Yeah. Good to see you.
All right, guys. So now we're going to actually get into the meat and potatoes here of this presentation. Can I get a show of hands here? Who has touched Claude Code, or do you even know what that is? Okay, so about 70%-ish or so, 2/3. Okay, all right. So for some of you, this is going to be a first time. For some of you, you've used it, probably trying to figure out where this application sits in your tool set. So we're going to jump in here, and let's see here. Let me see if I can figure out where my mouse is. There we go. All right. So here's what we're going to be talking about. We're going to be unleashing the power development, and I'm usually a walk and talker, so like standing behind here, getting my video or having a video is a little bit interesting for me. So bear with me. So really, this is a brief outline talking about the power of AI in development and some of the pitfalls. We're going to talk about Spark, which is a methodology to think about how to do development. So instead of just jumping in and being like, okay, Claude, do this, Claude, do that, we can provide a little bit more methodological approach to that type of development. And here's the specification for what Spark stands for, right? Specification, pseudocode, architecture, refinement, and completion. So we're going to go into a little bit of that. Then we're going to talk about Claude Code and understand where Claude Code fits, give maybe a brief demo, but then afterwards we're going to jump into our hackathon, which is essentially part of the reason why you're here. I'm hoping that you'll stay after the talk to do some experimentation and understand, and we'll, I guess, be vibing together. So with the goal here of really building some innovative products and like working with each other and continuing to build our community. So what are the specifications? What are we doing? What are we trying to build? That's really, at the end of the day, one of the fundamentals of what we need to define is what are we trying to achieve as we're trying to build something. Programming, functional programming, AI development, what are we doing? The best way we can do that is be both precise and concise. So if you're an entrepreneur, people talk about an elevator pitch. That is a great way to refine what you're trying to do. And I realize this might not have a lot to do with the specifics of programming, but without having an understanding of what we're building, it's hard to build. So we need something to shoot at. And it's the same thing for development in general, but it's the same thing for using these tools, is we need to understand what are we trying to do. The other part is keep it simple, stupid, right? The KISS principle, standard engineering principles. Same thing applied to all of the things that we're talking about here. And then the technical architecture is important. So really understanding like, okay, as we jump in, how are we thinking about building this? What tool sets are we going to talk about? And we'll talk a little bit more in the architecture slide, but like just get to think about what are the parts and pieces and what we're trying to go through. Second part here that we're going to talk about, or that we're talking about, I should say, is pseudocode. Now that we have our problem defined, how do we see things working together? And articulate that. So do we have a way in which a workflow happens? Do we have, what is our algorithm for this? And then really understanding where these parts and pieces and components can work together. really, at the end of the day, what we're trying to do is we're trying to talk about how would the architecture work together, and really discuss on what are the systems that we're thinking about having. Do we need to have something store information? Do we need to have what kind of frameworks are we thinking about? Is this a web? Is this going to be a web application? Getting back to what are we trying to do? Like where can the work happen, and can we write the algorithm to do that? The next part here is the architecture, right? The system design. So after we have the workflows defined, we talk about how the parts and pieces are going to work into that workflow. If we need a database, we're still going to need a database. If we need some sort of web UI, UX, we're going to need that. If we're using other tools that we might want to do some audio to text, utilize those, and then understanding how the different components within your infrastructure are going to work together. So, and understand that as you're building, scalability is going to be a part of what you're going to be building towards. So as you're building, think about that, and then iterate through. This is meant to be a framework for how to do the development. It's not meant to be the definitive framework of you have to do every one of these steps. So essentially, really define your technology stack, and define that across the board. Your data structures, right? I mean, anyone that's taken computer science understands data structures are really important. Still is an important aspect here to define that. Understanding the scalability and the components. So again, talking about the databases. Look, next thing is the security layers, right? How are you going to, say you're building an application, are you going to authenticate those people? What kind of security do you have in place to prevent unauthorized access? And define those within this architecture. Same thing is for the mapping of the journey. Like looking at the architecture and the pseudocode, how do those go together? Next part here, refinement, right? So we've defined our workflow, we've got our architecture. Now let's think about how do we make this better. So this is the optimization, right? So we've gone through the process to build something. Now we want to refine it a little bit to make it make it more understandable. Here's where we're going to focus in on like optimizations and the refactoring of code that might be developed through a Claude Code or something like that. Going in the rapid iteration with people that you're working with, and seeing the feedback loops. So because you have Claude Code, you can generate code much more fast. So these refinements take much less time. So if you've thought about like standard software development cycles, you might have heard of Agile, right? Agile development is now becoming much faster because you can start to generate code at a much more rapid pace. And you can get feedback from your customers and from your stakeholders much faster. So the idea here is that you really have a much more faster iteration cycle that you can refine your product. And then you can go back and look, does this architecture make sense? Or do I need to change different components of this? Does this workflow work? Maybe I need to go back and address that. So the refinement process is a continuous improvement process that you really need to incorporate into your product as you're designing it. And then one of the most important parts for Claude Code, or for these Vibe tools, is making sure you maintain your documentation and keep it up to date. Because as you're going through the development process, the refinement process, you may realize that you made a change. And maybe the change that you made was you changed your database. Or maybe you changed your authentication architecture. Well, if you don't update your documentation and you're using one of these Vibe Code tools that reads your source code, essentially, you might have conflicts within that. You might have what I would call cruft, or like the old code that's not been cleaned up. But as the language model is reading that, it picks up both of these systems, and then it gets confused, especially if your documentation doesn't say this is definitive. So making sure that that information is up to date and stays relevant, and then trying to remove the old components that have been deprecated as fast as possible. So really, the refinement process also gets into what did we learn as we're iterating, right? So understanding and bridging the gap between the initial architecture that we thought we were going to design and what do we end up with, right? This is the sausage making of computer science. Is we might have gone down this journey to try to build one thing, and through lots of iterations and working with stakeholders and specification changes, we end up doing something completely different. So trying to bridge that gap is going to be extraordinarily important because the refinement process here it's built in. Now you have a framework in which to work through and think about. It also helps reduce the technical debt. Again, getting back to if you change your architecture, next thing you know, if you update that, you update the documentation, make it clear, we're in a much better spot. So making sure you learn along the way. And the last part here that I'm just going to talk about, which is part of Spark, is really the testing and validation part. And I say this last, but it's absolutely not least. Testing and validation, especially using language models, might be one of the most critical components of doing development. Because you have a test case, and you don't have a test case that you can validate, how do you know your application's working? So typically you would think of this as like a CI/CD pipeline that works using Vibe tools to build out CI/CD pipelines. That also works. Also incorporating different aspects of CI/CD that you didn't think about, right? So you might have your functional program, but you also need to incorporate, if you're using like an LLM in your application, how do you validate your LLM? How do you validate those prompts? These are probabilistic systems, and you're trying to do something deterministic with a probabilistic system. Who thinks like that's going to go well? Show of hands, no one? Absolutely no one? You're absolutely right. It typically doesn't, which is why like there's a new paradigm that you really have to think about as you're going through the development of LLM-driven and incorporating LLMs in some way, shape, or form into your development. So utilizing tools, and I gave a talk last year on prompt foo, which is a great tool set to really help validate essentially the LLM prompt within your application to verify that it's working as you expect. So using those tools inside the CI/CD pipeline also is a core component here. And then the last part is like incorporating your monitoring and your maintenance. Really, like at the end of the day, the core concepts of system design and software architecture remain. In fact, I would argue they are actually more important now than ever, because if you don't, so it's just those just become no buenos. So now you're probably asking me, like, how can you think about utilizing these Vibe tools in your work? I will start out with a word of caution, and then I'm going to hand it over to my fellow speaker here. Okay? Words of warning. Think of these AI tools as being a junior developer who's strung out on crack. Okay? Like just someone that just can't stop moving, thinking, and will be more than happy to ask you to destroy your database on a whim just because it thinks that it needs to, and that's it. So essentially tread lightly and make sure you validate what any of these tools are telling you along the way. All right, with that said, here's your new collaborator, right? Claude Code.
Hey everyone, my name is Adam. I'm a principal software engineer, and I've been working a lot with Claude Code recently as well. So to kind of play off of what Chris has been talking about, I'm going to jump in and we're just going to skim the surface. There's probably a ton of things in this talk that we'd like to double click on, and we could definitely do that in the future, but I think this will be a nice overview of how this all comes together. Is it space? Nice. So we're really just going to be looking at getting good at Claude Code. So I'm going to start with just a brief introduction, super brief introduction of what Claude Code is for anyone who has not seen it before. It is an agentic, it's an agent that has been put out by Anthropic that leverages some of their large language models to interact and help you code. It's a command line tool, so you end up installing it on your machine. You go back and forth asking it different questions, prompting. For those not familiar with agentic processes, definitely go look at that. That's very important these days. But Claude Code has very rapidly become one of the, probably, if not the most popular, close to the most popular way of putting code out these days. Right alongside of Cursor, Windsurf, there's Gemini CLI now, but a lot of other companies have ended up copying what Anthropic did with Claude Code because the form factor was just so great. It really took to how developers wanted to build things. And so because it's in your command line, it's got a little bit more access to, like Cursor has some of the access that's available, or even Copilot in VS Code has access to what's in your codebase. Claude Code starts to flex a little bit more into what is accessible on your machine. It won't go above your root folder, but you can actually create some really interesting scenarios where you can do quite a bit more than just what Cursor or Copilot could do. So that's a brief overview of Claude Code. It's very, very good at helping you kind of write some of this code. And so we're going to dive straight in to kind of prime you guys with some things that help in leveraging Claude Code, which will potentially help with the hackathon as well. So the first thing you need to think about, especially with really any agentic system, is context management. So context management being, if I were to say to Chris, go build me that dashboard that I want, Chris would come back with something that probably is nothing that I want, right? Because it's all in my head, right? But if I said, go build me the dashboard that I want, it's going to be a financial dashboard. We want React components. We want it to be designed in this way. All of those pieces are context that I'm putting into Chris, and then Chris will give me a much more accurate response. It's the same thing with Claude Code. And we have to do a lot of context management with Claude Code. What code does it have access to? What are your business requirements? What is today's date? Claude Code regularly thinks it's 2024, by the way. Many, many different pieces like that. And the more context you can pump in, the better it tends to get. More accurate responses, more comprehensive responses. It gives you a much better build most of the time. And so it will manage its own context window. So we'll kind of come back around to managing context. But Claude Code, if you think about your context window, this conversation that we're having today, you guys, if I were to ask you at the end of the talk, what did we talk about at the beginning, you'd probably be able to remember that. You can think of that as the context window. If I were to ask you a year from now, what did we talk about in this talk, you probably wouldn't remember, right? So the context window is really just how everything that we've been discussing right now, and that's, I'm trying to map this to kind of how this works in the LLM. And so it will self-manage its own context window. Eventually, the context window gets long enough that it can't go back and reference pieces from the beginning of it. They're getting better at this, but it gets more and more difficult the more and more context you put into this window, whether that's external context or prompts that you're writing in or responses that it has returned. So Claude Code actually has a way of self-managing this. I don't know the exact token length, but when it gets to a certain point, what it does is it does this thing called compaction, where it will auto-compact all of the context that you've put in thus far. And what it does is it takes everything, it kind of pauses. It auto-compacts, it says you're at 0%, and it sends everything that you've put in, everything that it's responded to you with, and it will send that to the large language model, summarize it, and then put it back into your context window. And the idea there being that you're not going to lose track of that, and it's actually a little bit easier for Claude Code as the context window grows to reference things that you talked about in the past. And so it will do this auto compaction technique, which is pretty cool, but it also can be really problematic as well. When it comes to context management, if you're not paying attention to it, you might auto compact, like I have done many times, in the middle of a feature or while I'm halfway done writing a test, because there's a specific percentage when it does that. And that can be problematic because the way that it summarizes everything previously, it's summarizing something that's half done, and you might lose context. And so then when you go into this next portion, it might have no idea what you're asking about, even though you just talked about it. So there's a couple of different ways that you can manually manage context, and this is where Claude Code really becomes more of a primitive than a tool. It is a tool, but it actually can function like a primitive as well. You can build things on top of it. So they have these things called commands. There are these slash commands in there. And two I'm going to call out. There's more than just two, but the two that are really important is compact and clear. So compact is one where if I'm building and I'm done with a feature, I probably want to call slash compact before I move on to the next one, because it's going to in a tidy way, summarize everything I just did. And I know my feature's done. I'm not halfway through compacting my conversation. In addition to that, clear is kind of the opposite of that. So there are times where you want your context in there, but there's also going to be times where I'm moving off of feature A, I want to go work on feature B. Feature B has nothing to do with feature A. If I leave that context in the window there, it's going to be referencing that when I work on feature B, and that's a problem. So you also want to know when to clear your context out completely and say, I'm working on something totally different. So these are two tools that they give you. And that's just something that's really, really important to keep in mind when leveraging Claude Code, and will kind of come into effect when we start to build things in the hackathon here. Yeah, go ahead.
After building feature B, if I want to make feature C, which is completely related with feature A, how would you go about that?
That's a good question. So in the simple example that I just gave, you wouldn't be able to, right? You just cleared out the context from that. You can have, if you jump out of Claude Code and then go back in, it starts a new context window, and it has the ability to resume previous context windows. So a simple way to manage that would be, okay, I work on all of this stuff in this context window. You can even name it, and then move to another one and move back. Or, and this is my preferred way, there are ways you can sort of export that context. So I will sometimes, when I'm in the middle of something, say, summarize everything that we just did, go through all the steps. What do we build? What are our tests? Where did we leave off? Write this into a markdown file. I'll keep a docs folder, and then I'll move on to something else. And then when I want to pick that back up, I can say reference this markdown file. It will load it up into context, and then essentially you're storing a piece of long-term memory for it. So using markdown files as persistence in this case. And then there are other tools I'll get to later. Yeah. So the other cool thing about compact is you can even pull out individual pieces of your context to say, and I did not know this until like a week ago. If you call slash compact, you can put in there and say, hey, make sure to focus on just the UI elements that I built in here. And it will actually prioritize specific pieces of your context, summarize those so that your next questions that you ask are focused around that aspect. So it might be that I built some UI elements, maybe I did some API work, maybe I did a little bit of database work, maybe I did some testing, but maybe my next piece I'm only going to be building on UI again, and I don't care about the API stuff that I did. To keep the next portion of context lean and focused, I would basically say slash compact, please make sure to focus on the UI elements, prioritize those in your summary. And then of course clear removes the conversation history. So just as important, less exciting with clear, but just as important because you want to know when to remove context. Go ahead.
Is there a way, when you were talking about going feature by feature with context window,
Mm-hmm.
as you're writing prompts, I've had the problem that your prompt gets so long that the LM starts to have problems with it. Is there a way to measure and know when you're getting to the limits of context window?
So the question was if there's a way to measure and know when you're getting to the limits of the context window. There's a percentage that pops up at a certain point, but I've never actually measured when it shows up. I have started to experiment with this a little bit. So recently, within the past couple of weeks, they introduced a way to slash command. It's for modifying your status line, the thing that's underneath where you're actually typing stuff into. I don't have a script for it yet, but I'm trying to get exactly that, which is, give me a percentage or some sort of metric that tells me along the way where exactly am I at with my context. And so, yeah, I think there are ways. Obviously, there are ways built into the Claude Code SDK. There's probably ways you could pull it out that way. But that might be, we could talk about that afterwards. I think there's definitely ways to pull that off. Yeah.
Microphone? What I have found is that that's not reliable.
Oh yeah, I don't
Have
think.
you found that? Yeah.
Yeah,
that's what I'm
I
curious.
mean, I think to Chris's point, and I'll actually use a slightly better term, though I do love Chris's example. I've always called these savant interns, right? They've gone out and they've memorized all the books, every piece of code you can know, but they have no idea how to apply it. You have to walk them through that, right? And so my assumption at every step of the way, it can be relatively unreliable. I've had situations where the compaction has missed certain aspects. Yep. So I actually, and I'll kind of go over this here, what I've found is a combination of figuring out what are the pieces that are global and need to be persistent across multiple conversations, and what are the pieces that are just this specific thread. And when pieces are global, and this is where that sort of organic updating of this documentation goes, that's where I start to use like the Claude MD and a hierarchical structure with Claude MD to store those pieces that are always available in context. But yeah, it's a good point, and I think it kind of goes to Chris's point where you can't really trust these. We're working with weak assumptions on top of weak guarantees on top of strong guarantees, right? It's useful, but we want to build in strong guarantees first. So this feels better, though there's also caveats to this. It doesn't always respect what I've written in here. Typically, the way that I handle at least tuning, how accurate it is with compaction, or what it has available to it in certain threads, is leveraging the Claude Markdown file. And so the way that I like to think about this is you typically will put one of these at your root, at the root of your entire project. And you can think of this as, it's really your notes. So the conversation where I was talking about, if we were having a conversation now, if we refer back to it later, it's hard to remember exactly what we talked about. But if I took notes, I could come back to those notes and know exactly what I talked about. Claude Markdown file functions more as a long-term persistence of memory, a long-term memory for Claude. So it respects specifically this Markdown file. And you can write really whatever you want in it. The recommendation is to do a / in it, and it will look at your whole project and then build you an initial Claude MD. But what I do is I'll have it do an init, mostly for formatting, because it will out of the box do the formatting, and then I actually have other ways of updating this as I go. In addition to this, so again, you would put context in there, you'd put rules, you'd put guidance. Really, it's just for at the project level and across all of your different Claude Code threads. For each thread, it's going to load this in, so there can be a problem with having too much in here. There can be a problem with kind of blowing the token count, especially if you're not paying for the $100 or $200 a month that they charge. For example, at my full-time job, we're using an API token for everything, so we have to be very cognizant about how many tokens are we using. And so that's where I kind of get into a little bit more of the best practices. So like I said, use the init command for the initial bootstrapping of it. It does a decent job, at least for formatting, right? I tend to ask Claude, what is the best format that will help an agent understand what I'm writing, right? It'll give me a better markdown formatting than I typically would come up with. But then I'm going through and explicitly updating some of these things, whether it's the technology stack, whether it's my specific best practices. You want to keep it lean, like I said. You want to keep it as small as possible. And then if it is getting large, you would use a hierarchical structure. So you can actually put Claude MD files at the root of any folder. And so anytime that you're going in to build something, so I have a Claude MD file I use Convex for a lot of my backend. And then I have a separate Next.js front-end folder. I'll have two separate Claude MD files in those that are specific to what they're doing there. So in the front end, it will have front-end only stuff. In the back end, it will have back-end only stuff, guidance, rules, personal preferences. And then my root Claude MD is a little bit more of like, let me summarize this tech stack. Let me summarize what this project does. And what it will do is it will respect, if it says, hey, we're working on front end, it'll go into the front end folder, and it will always take the root file, but then it will append the front end file as well, but not the back end file, right? So you can keep your context separate there. And that actually keeps it from being a little bit more, like I've found it to be a little bit more confusing when it's trying to sort through everything versus, hey, don't even think about the back end when you're working on this front end piece, unless I explicitly say so, right? So that is something that doesn't come up as often when you're thinking about just using a Claude MD file, but it does respect the hierarchy of that. Yeah.
So are you writing it as MD, just writing MD yourself?
Yeah, a little bit of both, hybrid approach. Yeah, so
Claude can write some of it as well.
correct. I'll have Claude write some of it. I'll write more. I'll say, hey, this section is not being respected. Can you do a little bit of research online to see what are some keywords or things like that that we can put in that will cause? I'll ask Claude to help Claude, right? He's his own therapist. And so yeah, that's a good question though, and it does where I typically do a hybrid approach now, especially, and really I kind of go back to the formatting, right? I have had Claude come up with a formatting structure that I would not have been able to think of with Markdown that works much better in explicitly communicating across some sort of structure or sequence of events that I want it to do. That I just wrote, 1, 2, 3, 4, 5. It actually outlined it and had bold, and for some reason those things are respected a little bit more. I think consistency is respected more than specific items, unless they are keywords that have been baked into the models themselves. And they do have those proactively when it comes to sub-agents. It does respect that keyword. It respects, think hard, ultra think for changing different token modes. But yeah, so anyways, you can bake all of that into the Claude MD file. And this is really one of the things you want to start with when you're using Claude Code for managing context. So like I said, yeah, organize it hierarchically. You can reference other files as well. So I will sometimes keep, and this is less for managing token length. This is more for managing, it's dry principles, right? Don't repeat yourself. I don't like to have a bunch of stuff in one file. So I will put, if I have TypeScript-specific best practices for an AI agent, and maybe just generalized best practices. You can actually reference those in the Markdown files, and you can pull those in. You don't get autocomplete at all, but it does respect the @ symbol, and you can point it towards those. And that way you can actually compose some of these Markdown files out of different smaller best practices. Using capitalized keywords like critical and important tend to call out important instructions. Again, this is not something you can trust 100% of the time. I have multiple times found myself saying, it is important that you run the date function anytime you do a web search, because it's not 2024, please search for stuff in 2025. I'm getting to the point where it's respecting it most of the time. I think the biggest issue is some of my sub-agents, but we'll come back to that later. And then again, have Claude Code help you to make your Claude MD files better. Don't put 100% trust in it, but do have it help you, especially doing some research online for other people's best practices, funneling that back in, and then saying, okay, how could I expand upon this? Here's the problem that I'm running into. These are ones we're not going to get into today because we're not going to have enough time. But I do want to call them out as probably some of the more powerful Claude Code features, in addition to these help build it into more of a primitive. So there are some other frameworks being built on top of this that do actually help quite a bit more with accuracy. Custom commands is one. So we saw /compact, we saw /clear. They have a bunch of other commands that are built into Claude Code. You can build your own. They are just prompts. That's all it is. It just maps to a prompt. /whatever, then dumps your prompt in. The only difference is the custom commands will accept an $ arguments, and you can actually treat it so you can build out sort of a pseudo-coded CLI tool. So there's a bunch of really interesting things you can do there. I have one that creates linear issues for me. I have one that does an entire pre-commit workflow with multiple sub-agents. So it is really, really interesting. Custom sub-agents, same deal. They are roughly just prompts. But Cursor, Windsurf, anything now has MCP integration. Claude Code has the same. Again, another way to provide additional context. And then hooks, I think, are one of the more important ones, especially at the enterprise level, where you get a little bit more management of the life cycle. I have specific things in there that say never run an RM command, never access my .env file. So you can really tailor those hooks to fit more of a secure architecture, especially when leveraging these tools inside of a larger company. These are just additional libraries. If anyone is interested, I can provide URLs for them. These are all really interesting projects that are building on top of Claude Code. In the case of Taskmaster AI, it's actually not building on top of Claude Code, but it is an MCP server that helps you. You'd walk through, this is all kind of the spec-driven development. You'd walk through, build a PRD, and it will help you parse those into individual tasks. And then it does complexity research and things like that for you. Really, really useful for having an agent stay on task and not get lost with previous context that you work with. Archon is a really interesting project, part of a YouTube community that I'm part of. They just have this giant context management platform that they're putting together, along with some MCP servers that expose it's just a really nice way to manage your own internal documentation. Agent OS is a really interesting one for managing. It's more focused on feature specs. It has a really nice way for managing different layers of context. So my personal preferences, my company guidelines, our feature specs that we're building. So all of these are different approaches for how do I take Claude Code and work with some of the inaccuracies that we've run into, and how do we narrow this into a tool that can actually, the quality that comes out on the other side matches what we're used to doing when we actually write the code ourselves. The last two, Cloudflow and BMed method, are two additional really interesting tools just built on top of Claude Code. So I recommend looking at those on your own time, and if you have any questions, feel free to ask me about them. That's all I have.
All right, any questions?
Mm-hmm.
So I've used it a little bit.
Mm-hmm.
But it's very good. Management using all these MD files, that violates KISS.
Yeah.
So now you're like managing this crazy environment yourself.
Yep.
And you're going to lose it for sure.
Yeah.
So how much time are you putting into that?
For my full-time job, not that much.
Oh,
Yeah.
you're doing this on the side.
Well, a lot of the work that I do with Claude Code, I do on the side. And the goal for me personally is to figure out, okay, if we're moving in the direction of English language being our next layer of abstraction, right? Just like Python and JavaScript became the next layer of abstraction, how do we work within that space, right? So if I'm going to sit there and I'm going to work within, just building with Claude Code, how do I take my skills as an engineer and then apply that and make sure that the output of my code is always the same quality that I would have gotten if I was writing it myself? So management of the environment is one thing.
The thing, in my opinion, is that you're committing to something that's taking a lot of your time. If it's this complex, it's not going to last.
Potentially,
So
yeah.
You're putting a lot of time into something that's
So
probably not,
I'm going to push back just a touch.
Yeah.
A lot of the sub-Claude MD files, right?
Yeah.
Those are sub-processes. Those are sub-functions, right? You still need to define those. No matter what.
You're defining your environment. You're not even talking about your code. You're managing the environment, keeping up, and when you make a change in one place, you're going to change that all. You're going to remember which MD file to change.
So this is where applying the KISS principle, right? If you apply a hierarchical approach to that, right? So if you're looking at, say, you have, just like you have in your environment, right? If you apply a specific environmental change to one area, of course you're going to have a big mess, right? We call them BFMs, right? But if you think about, like, where is an environmental variable? Where does environments exist, right? They exist in the environment. You shouldn't have localized environmental variables. Well,
That's what all those MD files are full of.
they're full of definitions of what you're trying to do in that subdirectory, for example, right? So if essentially they're
I'll grant you that, but you know what? I think it's semantic. I don't think you can maintain. I think that sounds to me like an unmaintainable system at all points. That's my 2 cents. You wouldn't need to dwell on this here.
yeah,
That's all.
there may be. You may be right.
Yeah.
We're just trying to talk about how.
I'm just adding 2 cents.
Yeah, thank you so much. I appreciate that. Yeah, Jim.
You mostly use it for your test and validation, so that your MD files are really telling you fuzzy. Your MD files are really telling you what's important from a next layer up at the higher level. What's important for this function or this entire app to accomplish. if that drives your test and validation, then you get some independent input into test and validation. The problem that's been around for decades is that the people who write the tests for their code are the people who wrote the code. So they have all sorts of reasons to miss all the things that can go wrong, and all the things that
biases, right?
yeah, their own biases. Whereas if you've got a Claude MD that tells you what's crucial, what's important, what's the underlying reason for why this thing exists, this piece of code exists, then it's an independent way of doing of designing your and crafting your test and validation is all I'm saying.
Yeah, but when I use AI code, it writes its own tests.
It writes its own tests, but it's got kind of the same, it seems like, that a human who writes their own tests, of course. You're not using, it's not necessarily the case that the engineer who's responsible for that piece of code is intimately familiar with Claude MD, and that he keeps it up to date, and he keeps, the worst possible thing is if your specifications and your documentation lag behind your implementation.
So the thing about maintaining the documentation is that you're refactoring the code all the time. So at what point do you document? From which point are you not,
Well, that's assuming that refactoring works, that it's efficient and effective, and that
My question is when documentation is super important, but it's also, I think it's an art to know when, when to use it and how. Because you could be spending a whole hour refactoring and getting documenting all in all. So anyway, it's complex.
But this is exactly why we talked early on about the Spark principle, right? Is really getting back to the specifications and the architecture and being able to redefine and refine our process, right? I mean, how many people have developed applications that were ever, in their opinion, complete? No one. Okay. Exactly my point, right? Is like we can always consistently refine. We can always consistently look at doing better. But at some point we have to define, like this is marked as production. We're going to flag this, ship it, and go, right? And at that point we create the documentation. Yes, probably creating the documentation along the way is a better approach to this, because now as you're creating that documentation, you can go back and reference why you made those changes, right? So, and this is part of why I started this talk about that principle, about understanding this, so we don't get down those paths of like, where do I go? If we have a framework that we can work through and think about, now we can do better development because of that. Because a lot of times, all of our development, I'm guilty of this as much as everyone else, like, start out like, hey, look at this. This is a brand new tool. Yay. And Claude, or wherever, you just start working on something, building it up, like building it organically, and not really thinking about the specifications until it's too late, and then you have to go back and refactor everything, and then you break a bunch of stuff, and then this and that, and next thing you know, you have something unmanageable. It's the same process, just we can do it faster because we have crack code Claude. So that's why those design principles are so important, to think about what are we doing ahead of time. Because it's the same architecture, it's the same specifications, and it's the same pseudocode, the workflows. How do these work together? And making sure we define those ahead of time, but then refining those as we go. And increasing the documentation along the way helps get us there. But it's not going to be the end.
I just want to say, I think it's important to remember that we're at the early stages of figuring out how humans should talk to the AI and get it to help with whatever you're working on. And so this is one step ahead instead of just a plain LLM, having context and various, the MD files and ways to try to communicate better with Claude. And in a couple of years, there'll be something better than that.
Way less than a couple of years. It's already there.
And I really appreciate the questions, and you're absolutely right. There's lots of ways we can screw this up. We're trying to at least give some guiding principles of how we can do better. So maybe you guys can learn from our mistakes along the way, which is why we're here. All right. Any other questions? Nothing? Crickets? Chirp, chirp? All right, there we go. Thank you.
My understanding is Claude is currently considered possibly the best LLM right now for composition. Going off of that, I'm wondering at what point would you not trust Claude anymore? If you're working on, like a real startup or something, is there some kind of limit? At some point it's too complex for you to do things through Claude, or I'm just wondering, working on a project, what could trip you up eventually if you're working on it for months using Claude?
I'm happy to take that one.
Go for it.
Right now, don't trust it from the very beginning. Use it, but don't trust it. That's the way that I work with it. The way that I've been considering this moving forward is I've been using the example of the calculator being a perfect abstraction for the way that we calculated previous to that. When Claude is able to get the right answer every time, then you can trust Claude. But at this point, I would say right now, from the very beginning, you should be baking in a process. We are constantly reviewing. Some of that might be hybrid. You might say, hey, I have this Claude instance, and then I have another Claude instance where I want it to write a review, but then you should still review its review, right? So there's never going to be a hands-off piece. And if anything, I think as a company gets larger, it's going to be less and less so, because that context that we talk about, especially these legacy code systems. I work at a company that's got 12 years of bad legacy code, some of which I wrote 6 years ago, right? And that is stuff that is very hard for it to understand. And that's really the difficult bit that we're working with right now. But I think if you start from the very beginning, not trusting it, you'll build practices around leveraging it in a way that helps speed up your time using it, but also making sure that you have quality on the other side.
I have a follow-up question on the current discussion. What are some vulnerabilities of Claude Code that we should watch out for when making a hackathon project?
Sure. There's a few, and there are some ways to mitigate them. For a hackathon project, it's probably best to run it inside of a container, especially because you can actually, Anthropic does give a dev container setup that you can leverage, complete with some firewalls rules, and so it can make sure that it's not. I think reaching out to random parts of the internet to bring things back in is probably one of the bigger vulnerabilities. So being able to approve some of the web searches it does. I believe, though you can maybe correct me if I'm wrong, I don't think it will reach above the folder that it's in. So it is kind of locked into when essentially when you're trying to reference something outside of the folder you're in, it won't do that, but I could be wrong about that. And then, just like it can run any command you want it to run, right? So it can run rm, rf, everything. You can lose your whole project that way. So certain things like that. So just making sure that you're checking along the way. Don't approve. There's ways that you can approve certain tool usage. I tend to not do that for a long time, right? Especially if I'm starting on a new project. I want to see what it's doing, the way that it's leveraging the context that I've given it. And so I tend to go through and I'll approve every tool usage.
I'm going to give a very simple one. Don't give it root.
Yes.
Okay? Like, don't give it sudo access. Don't give it root. Yeah. Like, keep those as your own, okay? So just to limit the permissions it has to update. The other thing I would recommend is tie your project to Git. So as you're making updates, make sure that you're committing those changes and function and validating those changes along the way. So you can always go back if Claude just decides it goes off on a tangent and decides to refactor your entire code base along the way and say, hey, listen, I broke every function you had before. So using Git is a nice fail-safe as well. Yeah.
All right, so I have a question, which is to compare Claude to my earlier experience using code generators. So my experience with code generators is that they're really handy for getting prototypes out there, for doing that refinement, to getting to know what the final product should look like. But the code that they generate tends to be bloated and a little obscure. And so for production, then I would rewrite it. But having gotten to the point of knowing exactly what went into the production system was extremely valuable. Is that similar to what you see happening with Claude?
It can be. I think especially with some initial proof of concept, yes. I can only speak from personal use, right? Because I mean, this is like, to everyone's point, this is early days, right? So there aren't best practices. From personal use, I've been able to take it beyond that point, but I think that is because I take a hybrid approach, right? Where sometimes I'll ask Claude to do certain things, other times I will then go and I'll either review it or I'll go and change it myself. I've found that it can take it a little bit further, and I think some of that has to do with specifically the Claude Code agent, which there is a video, and I don't have a link for it right now, but there is someone who used WebCrack to take apart the published Claude Code and actually look at, they used a proxy to track all the things that were getting sent back and forth from your local Claude Code to the actual LLM APIs. And they broke down the whole process of how Claude Code works in addition to the actual prompts that it uses. And a lot of Claude Code is built off of very careful prompting from Anthropic internally. And I think that's why it has gotten so good at what it does. It's really just they've tailored their model to fit their style of prompting. And I've been able to, I don't think I've ever gotten stuck with bloat, but that's just because I've also been very careful to pause along the way like I typically do with code and just go clean stuff up. I don't know if that's a perfect answer to, yeah.
This might be way out of line for questions, but as I age, my memory fades a little bit, you know, and I'm more of a tinkerer. And I keep saying, where the heck was that piece of code that I did to do X? Now, can Claude Code be something like a historian for me, or to say, hey, go to my own code base and say, here's the thing, I worked on it a while ago. Could you please resurrect that for me and tell me what I was thinking at the time I did that?
Only with additional processes built around it. So by default, no, I wouldn't trust it to do that. I've seen several implementations of, so like I said, I'll work back and forth to get markdown files stored in a docs folder, mostly around speccing out something that I wanted to do. So for example, I think like many engineers, you'll get into working on a feature, you'll notice something else that's wrong. You're trying to avoid scope creep, but I still want to capture all the context that I had in that moment. So I'll sometimes go back and forth and say, okay, I'm not going to work on this right now, but I do want to capture that I noticed this during this other feature that I was working on. How do we store this? And then kind of go back and forth a little bit until it actually has written out the markdown file. I'll then read it and say, okay, great, this captured my thought process at this time. There are other libraries that have played around with using SQLite locally to store longer-term persistent memory across multiple agent runs. So I think with additional tooling, you could probably accomplish something like that. I don't know that it would be accurate as just booting Claude up and saying, hey, what was I doing over here at this time? That's a little bit too unreliable. It wouldn't be able to get all of the context it needed to answer that.
Though, if you do have everything like in a Git repository, you can actually tie Claude, not Claude Code, but just Claude to that Git repository, and then you can ask it, is it within this repository, is anything that I have referencing what I'm thinking here, and get a better idea. was this something I did or not, or is it here or not? It's not going to be perfect, but I'm just kind of brainstorming here as some thoughts. Other questions? I think I still owe you a...
Well, I was going to ask. So you're validating all the code that is producing. I don't think that does work.
Oh, yeah. It might not
I
be.
listened to every one up to one to see if I think the microphone's working. I don't think it is. Is it, so you're validating all your code,
Pull requests.
right? So we can't all do that, right? And
Sure.
that's, AI can write so much code.
Mhm.
So, I wonder on the industrial scale how people are going to
Yep.
deal with that. Because you can't validate it by hand.
I agree with that. Anytime I've personally gotten to the point where there's been too much code being output, because I don't want to spend hours looking at a pull request, I'll instead turn back to how am I breaking down the problem. There have been, Claude 3.7 was known for this. It would go way beyond what you were trying to currently do, and it would say, hey, I know you wanted to do that, but also I went and fixed this, and this. And all of a sudden you've got a 150 file pull request, and I deleted most of those. I said, well, it took you 5 minutes to write this, let's delete it and start over. Claude 4 has done a better job at staying more topical on what you asked it to do. But I agree, yeah, I don't have the time to do giant pull requests all the time. I don't have the time to do that when a person writes it, and I've had that as well, Oftentimes I'll say, you need to break this down into smaller pieces, or I'll go to the product folks and say, we need to have managed this better. So the way that we chunked this story, it's way, way too big. And so we need to chunk these stories down into smaller manageable pieces. I'm fine with taking 91 files of change and, reviewing 3 separate 30-file pull requests, so even 30 files is a little bit long. But I tend to go back and look at how did I chunk up the product requirements or the feature specs.
But even just the whole structure. There's one thing, you're bringing up the real piece of code, but
Mhm.
just the structure is.
Yeah, I mean,
Here's a question for you. So I've been fooling around with this stuff for a while.
Mhm. Yep. Oh, I think about that all the time. Yeah, I mean, there's no way I can't think about that working with these tools on a daily basis. Yeah. I don't know that I have the answer for that one. Yeah. Right. Especially if they invent their own language that's faster. Because at this point, what I've talked about with folks is, especially when I'm selling some of these things at work, I'm talking to my boss and saying, hey, I think we should build this, and this. They say, okay, where can we use AI? Because we're doing AI first. I'm like, well, as much as I like to advocate for how cool this is and that we should be experimenting and learning it, when it comes to a full-scale enterprise, I actually tend to move towards non-AI automation first, but everyone wants to hear AI as part of stuff, right? And so what I like to do is I say, well, why don't we start with, because otherwise, to your point, you're losing track of your mental model of how everything comes together. So I try to follow the crawl, walk, run in larger situations where it's like, why don't we just automate the thing that we didn't automate first with regular, everyday automation methods? And then we can see, okay, maybe this particular node can have some agency to it. Even though right off the bat, we're going to want some human in the loop there to make sure that we've prompted it correctly and that it's regularly outputting and we have output validation and things like that. Yeah, I don't have an answer for your bigger questions. I think we should all learn. Yeah. I think we should have more of these and make sure to share that so we know when our jobs will be replaced. Yep. And that's why I think it's important to work with these things on a daily basis, but be very cognizant of where is the threshold of working with this from an experimentation standpoint and working with this in a production system that is now mission critical, right? We're not ready for that yet.
So in the recent IEEE publication, there was an experience report from AMD about using AI for code, and they said they found it quite
Yeah, had really good luck with especially large stack traces and just pasting that directly in and just pointing me in the direction of, where did this problem occur. I could spend time looking at it myself, but, oftentimes it's able to read it a little bit more efficiently than I can. Especially if you keep it narrow. Something we didn't mention in here is planning mode in Claude Code, which is super important when using it. It defaults to this auto accept edits. You actually want to flip over to planning mode where it won't change anything for you. And you have a conversation back and forth for a while first. And so actually the debugging is a good mode where it's, I don't want you to write any code yet. Just tell me where the problem is so I can understand what's happening here.
Wait, so given your most recent statement, so you're saying that Claude will automatically write directly into your code base? Because I remember in ChatGPT and other things, you write a prompt, it gives you a code snippet, then you copy and paste.
Oh yeah, this will write it directly into your code base. Yeah, it runs on the command line in your actual your directory structure.
That sounds a lot more dangerous than you doing the manual copy.
It is a lot more dangerous. Yeah, which is why. Yeah, it's a lot faster. You get a much richer. Well, the way that the agent itself works, you get a much richer context window because if you're doing this in a web UI, it doesn't have access to your code base, right? But there are things built in, and again, we didn't go into them, but that was some of the things I mentioned at the end. Hooks are something that are super important for making sure that you're not doing, Claude Code is not doing something that you don't want it to do, right? You can just flat out stop certain commands.
So I think this is a good
pausing point. Yeah.
Pause and take stock. We have lots of pizza here. Please also sign up for IEEE Computer Society volunteer. This is only partly possible because of IEEE. So please consider also joining IEEE as well. And with that said, I think we're going to end the talk right now and then dive into Claude Code. And we're going to give a brief demonstration of doing something with Claude Code here on the command line so you guys can see it actually in use. And then we're going to wheel these tables out, and if anyone that brought a laptop can dive in and we can run our hackathon. How does that sound to everyone? Beautiful. Well, thank you. Thanks for attending, and have a wonderful